Hi, this is lessons 12.1 and 12.2 for Algebra 2. We'll be doing these two together. They're sequences and series and arithmetic sequences and series. So our big question here, how can you write an expression for sums such as 5 plus 10 plus 15 all the way up to plus 50? So how can you write an expression for that sum? Okay, so look at your frame and let's fill in our is about and our so what statements. So sequences and series, this side of the frame is about what a sequence is and what a series is. So knowing the difference here. Our so what down at the bottom is do you know the difference between the two? So by the time you're done with this frame, you should be able to answer and tell what's the difference between a sequence and a series. So looking here at sequences, a sequence is an ordered list. The items in the list are called terms. The domain are the consecutive integers, so the domain usually starts with 1. And then the range are the values or terms in the sequence. So a sequence can be specified by a rule. And in these 3 problems right here, we're given a rule, and we need to write the first 5 terms. So for the first one, we're going to do f of 1 equals, I'm putting 1 in for n, so I'm going to say negative 3 to the 1 minus 1 power. So that's negative 3 to the 0th power, which is just 1, because anything to the 0th power is 1. F of 2 would be negative 3 to the 2 minus 1, and I put parentheses around those because you'll have to have those parentheses in your calculator. So really that's negative 3 to the first power, which is negative 3. F of 3 is negative 3 to the 3 minus 1 power, so that's really negative 3 to the second power, which is positive 9. F of 4 is negative 3 to the 4 minus 1 power, so that's really negative 3 to the third power, which is negative 27. And then f of 5 is negative 3 to the 5 minus 1 power, which is really negative 3 to the 4th, which is 81. So my first 5 terms are 1, negative 3, 9, negative 27, and 81. Those are my first 5 terms for this problem. For number 2, write the first 5 terms of a sub n equals n plus 4. So again, we're going to plug 1, 2, 3, 4, and 5 in and simplify. So a sub 1 is 1 plus 4, which is 5. A sub 2 is 2 plus 4, which is 6. A sub 3 is 3 plus 4, which is 7. A sub 4 is 4 plus 4, which is 8. And then a sub 5 is 5 plus 4, which is 9. So my first 5 terms are 5, 6, 7, 8, and 9. Those are my first 5 terms. For number 3 here, it says write the first 5 terms of a sub n equals n divided by the quantity n plus 1. So a sub 1 is 1 divided by 1 plus 1, which is really 1/2. A sub 2 is 2 divided by 2 plus 1, which is really 2/3. A sub 3 is 3 divided by 3 plus 1, which is 3/4. A sub 4 is 4 divided by 4 plus 1, which is 4/5. And then a sub 5 is 5 divided by 5 plus 1, which is 5/6. So notice for all of these, I just plugged in the number of the term, the domain, and got out my answer after I simplified, got my range out. So my first 5 terms are 1/2, 2/3, 3/4, 4/5, and 5/6. Those are my first 5 terms. So we just talked about sequences. Sequences are just numbers, patterns. Okay? A series is a summation of a sequence, and so you add the specified terms. Summation, it means adding. So summation, or sigma notation, can be used to write a series. So sigma notation looks like this. At the bottom, you have the starting number. We're going to start within the domain. Okay. At the end, at the top, you're going to have the ending number, and over here, you're going to have an expression. So let's try some of these. So our examples, find the sum of the series. So notice down at the bottom, we're going to start with I equals 1. At the top, we're going to end with I equals 5. And then our expression is 8i. So our first term is 8 times 1, which is 8. Our second term is 8 times 2, which is 16. Our third is 8 times 3. So notice for all of them, I'm just plugging in the number of my term into the expression to get what my term actually is. So 8 times 3 is 24. For the fourth, that's 8 times 4, which is 32. And for the fifth, that's 8 times 5, which is 40. So to make this a series, we now have to add all those numbers together, and you would get 120. So this equals 120. For the next one, find the sum of the series. And so we want the summation from k equals 3 to 7 of k squared minus 1. So our first that we're going to start with k being 3. So this is 3 squared minus 1, which is just 8. This is 4 squared minus 1, which is 15. This one's 5 squared minus 1, which is 24. This next one is 6 squared minus 1, which is 35. And then this last is 7 squared minus 1, which is 48. And then to find the summation, we add them all together, and you get 130. So for this last one, I suggest you pause the video and try this last one on your own. Okay, you should have tried this on your own. So notice we start with n equal to 0 and end at 4, and then we're going to add these all together. So we really have 0 to the third, plus 1 to the third, plus 2 to the third, plus 3 to the third, plus 4 to the third. So if you simplify that, that's 0 plus 1 plus 8 plus 27 plus 64. And if you add them all together to find the sum, it's 100. So at this point, you should know the difference between a sequence and a series. A sequence is just an ordered list of numbers, and then the series is when you actually add those numbers together. So if you flip your frame over, let's look at the other side. So now we're talking about arithmetic sequences and series. So this is about what an arithmetic sequence and series is. So an arithmetic sequence is a little bit different. What an arithmetic sequence is it has a constant difference between terms. So in order to see and figure out if it's arithmetic or not, we have to ask ourselves, is there a constant difference? So for this first example, it says, is the sequence arithmetic? So let's look at our difference. From -4 to 1, we add 5. From 1 to 6, we add 5. From 6 to 11, we add 5. From 11 to 16, we add 5. So that's definitely a constant change. So yes, it's arithmetic. For the next one, from 3 to 5, we add 2. From 5 to 9, we add 4. That is not constant, so this is not arithmetic. So to develop a rule for an arithmetic sequence, we have a little formula here. The nth term of an arithmetic sequence is found using this formula right here. You're going to need to know this formula and be able to use and apply this formula very, very thoroughly. This is where a sub 1 is the first term, d is the constant difference, and n is the number of the spot on the list. So let's try this here. So our first example says write a rule for the nth term. So we've got our formula up there. We need a sub 1 and our constant difference. So a sub 1 is pretty easy. It's the first number right here. It's -2. So a sub 1 is right here. And let's look at our constant difference. From -2 to 3, we add 5. And let's look and see if that's the same. From 3 to 8, yep, you add 5. From 8 to 13, you add 5. From 13 to 18, you add 5. So positive 5 is my constant difference. So let's plug a sub 1 and our difference into our formula and simplify. So a sub n equals a sub 1, which is -2, plus my difference is 5 times the quantity n minus 1. We're going to distribute to get rid of those parentheses and do a little simplifying. A sub n equals -2 plus 5 times n is 5n. 5 times -1 is -5. So simplify a little more. So a sub n equals 5n minus 7. So this right here is my formula. Find a sub 20. So a sub 20, we're going to just use our formula. So that's 5 times, instead of n, I'm going to put 20 in its spot, minus 7. So 5 times 20 minus 7 gives you 93. So a sub 20 is 93. Now let's look at our next example. So we're really plugging in what we know and solving for what we don't know in these problems. So it says one term is a sub 19 equals 48, and d equals 3. So we know an a sub n value, that's 48. We don't know a sub 1. We know our d, our difference, that's 3. And we know n as well, n is 19, because a sub n is a sub 19. So we're going to plug in what we know and solve for a sub 1. So for a sub n, I'm going to plug in 48 equals a sub 1, we don't know, so we're going to keep that a sub 1, plus my difference is 3 times the quantity n, which is 19. See right above where I wrote this 19, it says a sub 19 minus 1. So if we simplify, we have 48 equals a sub 1 plus 3 times the quantity 19 minus 1 is 54. So solving this for a sub 1, if you subtract 54 from both sides, a sub 1 is -6. So we can write our equation here. Our equation is going to be a sub n equals -6 plus 3 times the quantity n minus 1. Now we do want to simplify that, and you should go through and simplify that by distributing, and once you do that, you'll find that a sub n equals 3n minus 9. And I found that by going 3 times n is 3n, 3 times -1 is -3, -3 plus -6 is -9. So now we want to find a sub 100 using this formula right here, because there's our general formula. So a sub 100 equals 3 times 100 minus 9. So a sub 100 equals 291. So notice for both of these problems, I've had to solve for what I don't know for number 2. For number 1, I was given both a sub 1 and d, so I could just plug them in and simplify. Let's look at number 3 here. It says the first term is 6, so that's really a sub 1, and our constant difference is -4, so that's d. So they gave us a sub 1 and d. We can just plug them into our formula and simplify it, and then we can find a sub 20. So a sub n equals a sub 1 is 6 plus my constant difference is -4 times n minus 1. Let's distribute to get rid of those parentheses. I've got a little more space here, so I'll do the work. A sub n equals 6 plus negative 4 times n is negative 4n. Negative 4 times negative 1 is positive 4. So I've got a sub n equals negative 4n plus 10. And there's my general equation right there. Now I want to find a sub 20. So a sub 20, I'm going to plug 20 in for n. That's negative 4 times 20 plus 10. So a sub 20 equals, if you simplify negative 4 times 20 plus 10, you get negative 70. So there's our arithmetic sequence column. That's how we write a sequence, how we know if something is an arithmetic sequence, and how we use our formula. Let's look at the other column. So now we're doing arithmetic series, and as you already know, we just looked at on the other side of this frame, a series is when you add all the terms together. So an arithmetic series is the sum of an arithmetic sequence. The sum of an arithmetic sequence can be found using this formula right here. So we're going to use this formula. It's one you need to know and know how to apply. So let's do an example problem. So our example, find the sum from I equals 1 to 28 of the quantity negative 2 plus 4i. So our n is how many terms we have. So we start with 1 and end at 28. So n equals 28 because we have 28 terms. A sub 1 is what you get when you plug 1 into our expression. We don't have that yet, so we need to find it. So a sub 1 is negative 2 plus 4 times 1. 4 times 1 is 4, plus negative 2 is 2. So that's my a sub 1. A sub n, so that's a sub 28. We don't know that as well. So a sub 28 equals negative 2 plus 4 times 28. So a sub 28 equals, if you simplify that, you get 110. So let's now use our formula. S sub 28, because I have 28 terms, equals n, which is 28, divided by 2, times the quantity, a sub 1, which is 2, plus a sub n, which is a sub 28, which is 110. And then if you simplify that, s sub 28 equals 1,568. So we had to first find a sub 1 and a sub n before we could plug them in and use our formula. Let's do this second example, B. The sum of the first 20 terms, so that's n equals 20, of negative 2, so negative 2, there's my a sub 1, negative 2, negative 5, negative 8, negative 11. Now, we need to know a sub 20. So a sub 20 equals, well, we can't use the formula in this column. We're going to have to go back and look at our formula from the other column, our arithmetic sequence formula. So a sub n, that's a sub 20, equals a sub 1, which is negative 2, plus d, that's our constant difference. And if you look, from negative 2 to negative 5, it's subtracting 3. From negative 5 to negative 8, we're subtracting 3. Negative 8 to negative 11, we're subtracting 3. So our constant difference is negative 3 times the quantity n minus 1, and n is 20 minus 1. So again, I'm using my formula from the other column, my arithmetic sequence formula, to find a sub 20. So a sub 20 equals, if you plug that into your calculator and simplify it, this is really all you need to do, plug them in and simplify, you'll find that a sub 20 is negative 59. So now, let's use our arithmetic series formula. So s sub n, well that's s sub 20, because we have the first 20 terms that we're adding, equals n, which is 20, divided by 2, times the quantity, a sub 1, which was given, that's negative 2, plus A sub n, a sub 20, which is negative 59. So again, if you put this in your calculator and simplify, which you should be trying these, you should be putting them in and simplifying, you'll get negative 610. Our last example here says John has a first year salary of $32,500. So that's the first year, so it's a sub 1. He gets a salary increase of $1,750 each year. So that's my constant difference. That's the D. A, how much does he make in his 15th year? So we're really trying to find A sub 15. It's just how much does he make that year. We're not doing a sum yet, just how much that year. So A sub 15 equals, let's use our formula from the other column again, A sub 1, which is 32,500, plus my constant difference, which is 1,750, times the quantity n minus 1, n is 15, minus 1. So if we simplify that, you'll find that A sub 15, you should put this in your calculator and make sure you can use your calculator correctly. A sub 15 equals $57,000. B, how much, I should say has he earned in his entire 15 years of working. So how much has he earned means we would add the amount he made for every single year. So that is definitely an arithmetic series, so we're going to use our formula for arithmetic series. So we want S sub 15, how much has he made in the first 15 years altogether, equals N, well, N is 15, there's been 15 years, divided by 2, times the quantity, A sub 1, how much he made the first year, which we identified as 32,500, plus A sub 15, how much he made in his last year, that's 57,000. So if you simplify that, put it into your calculator again, make sure you can use your calculator correctly. If you can't use your calculator, you're going to struggle on these. So S sub 15 is $671,250. So that's the total that he made in the first 15 years of his career. So please make sure of a couple things, that you can use your calculator on all these, that you know how to plug these things into your calculator. And also make sure if you had any questions, any examples that didn't make sense, make sure you starred them so that we can talk about them in class tomorrow. Have a great day.